All right, let's take a look at this coding challenge with the base R approach and with the benefit of a little bit of practice that I've done before recording this. So, as usual, we're going to clear out our workspace so that our environment is empty and we're not accidentally using some solution that we've figured out and snuck in the back way. So, we've cleared everything out. We're going to load in our population data with read.csv, our flows data with read.csv, and then we're going to combine them. In this case, it actually looks a lot easier than in the tidyverse. We just hit merge. Now it takes a little bit longer, it's a little bit slower, but it's doing the same thing as an inner join, which we'll talk about as we get more into the tidyverse way of doing this. So an inner join, what that means is we've got a bunch of rows of data in flows, we've got a bunch of rows in pop. These should have same state and county names in both, and it's matching those up and assembling the data on that basis. But there are some rows in one data set that don't correspond with anything in the other, and vice versa. So for example, in one of these data sets, I'm pretty sure that there's a formatting error in a particular county in New Mexico. In one data set, it has an accent, and the other data set, it doesn't, and so they're not going to match up properly. The one without a data set, let's say it's in the population, we're not going to see a corresponding data flow thing. And then that same county with the accent, we're going to see it in the data flow thing, but we're not going to see corresponding in the population data. We're not going to sweat that here, right? So we lost basically both of those. We lost a bunch of data with this inner join, but we're not going to sweat it, right? So there's one that's definitely an issue with the formatting of the name, and there are a few that get dropped because they're teeny tiny counties and weird stuff happens with tiny places. But for our purposes, we've combined these two data frames, and this is important. Often you want to understand something that requires data from two different places, and what you've got to do at that point is you've got to bring that data together into one thing that you can do something with. So the first one thing that we're going to do something with is we're going to use the flow information and the population information, which were in separate data frames. We're going to use that to calculate the flow as a percentage of population. The way we're doing that is we're referring to df. $sign gives us access to the columns within df. Now there are a few different ways. I'm going to show you really quick. So df dollar, let's say b to a flow, right? That's going to give us that column, and it's going to give it to us as a vector, right? In this case, an integer vector. That's good. df, we can also use square brackets, and we can, for example, say 1, 1, which will give us the first row and the first column. If we do 1 to 3, that's going to give us the first row and the first 3 columns. If we did 1 to 5, 1 to 3, it's going to give us the first 5 rows and the first 3 columns. If we said 1 to 5 and then a blank, it's going to give us all the columns. Right? So there's different ways that we can access chunks of a data frame, and this is really helpful to do on the console to see what you're doing, to make sure that the changes you're making are appropriate, that they make sense. So let's just take a look there. Things seem fine, right? Nothing seems terribly broken. When we look at all the columns, it looks like we've got our population data, births and deaths, and then we compare that B to A flow. Things look fine. So we've merged everything. Now, with the $sign, we can not just access, we can also create. So we're creating and placing this calculation into this new column called in percent, out percent, total percent, and net percent. So we're taking how many people move into county A from B, how many move out from A to B, how many move between these two in total, back and forth, and how many move on net. So I believe the way to read net is the higher the value, the more popular that county is. But we'll double check that in a second. I had an approach here. We'll see if I need this. Um, right. Sorry, I'm remembering what I set up yesterday. So line 12, what I'm doing is just making it a little bit easier to use the by function further down. So the by function allows us to do a calculation by group, right? So the group we're concerned with here is state-county combinations. Now it's very careful to get both, because if we just looked at county names, we would be mixing up some counties. So Suffolk County is a county in New York, but it's also a county in Massachusetts. It's the county that Boston is in. So if we combine Boston with Suffolk County, these are two very different places, and mashing those up as though they're the same thing is going to give us useless output. Now in this project, our concern is not to get useful output. It's just to get the tools to get some sort of output. But it is very important to be able to do this sort of a thing where you're grouping something and doing calculations by that group. So creating this extra variable called unique location, that's just going to take the state name and the county name, paste them together into one thing. So there's going to be a column of states, a column of counties, and a column of state-county combinations. We throw that together, and then when we calculate the mean in percentage, we are calculating on the data, which is in the column in percentage, organized by the indices that we find in unique location, and applying the function mean to get the mean value there. And then we'll have median, min, max, and standard deviation. And we can do these for in, out, total, and net. I got a little bit lazy here and just did in and out. For this project, that's good enough. Don't sweat it. You don't have to be completely exhaustive. If you're getting a couple of these things, you're getting a handle on the tools. So, mean in. We're going to calculate the mean. Whoops, where'd it go? We're going to calculate that mean in percentage by unique location. Let's see what we get. So mean in, we're getting all this weird stuff. Wyoming, Weston County, that's our unique location. And for that, our mean in is 0.001690381. So we've got that. We've got 3,140 values. Now that's going to be tricky because our population, we've got 3 counties that have been thrown out here. Those 3 counties, I'll bet one of them is Donna Ana County in New Mexico, which has a formatting difference in these 2 data sets, which is really annoying, but we're not going to sweat it. But the good news is, since we have this unique location attached to this, so we look at names of mean in, we got all these unique locations, so we can use that to merge this back in with the population data so that we get something usable, right? So we're not just looking at 3,140 numbers, right? We can pull that back into our data frame and use it. So let's calculate all of these. We got all those values. We, in all cases, dropped those 3 counties. Should be a couple in Alaska and then the one in New Mexico. Now, what I did here is I took all of those values we figured and put them into a data frame. Now, there might be another way to do this. There's probably a nicer way to do this, but this will do the trick for now. So mean in, I'm creating data.frame. Let's put this full screen so we can see everything. Oh, whoops. I just closed that file. Main base R. There we go. Sorry. So mean in, we're creating a data frame. So before we had a vector that named each element. The data frame is going to have a column called mean in, which is going to take the data from the mean in we just calculated. Just to emphasize that this is a name and not the same thing. I'm going to call this one mean in rate. I'm going to be lazy with the others. So mean in rate is the data from mean in that we just calculated. And unique locations is going to be a second column in this mean in data frame. And that's going to be comprised of the names of the mean in vector that we started with. That's again just to specify. Let's call that mean in df. The other ones, again, I'm going to be lazy. So we're making a thing called mean in df that is a data frame made out of the mean in vector and the names from the mean in vector. The way I did it here, it's the same thing. It's a little less clear that this is a different thing than this, right? Median in equals median in. But this is a name of a column in the data frame we're making. And the data for that column is this variable that we created that is these 3,140 numbers. So let's go ahead and go through each of these. Ditto for out. And then we're going to also add this column to pop. Although let me go back and check these errors because I wasn't looking at this. Error cannot coerce class by to a data frame. Sure you can. You can coerce whatever you want if you coerce hard enough. This data frame, yada, yada, yada. I wonder if we do as.vector. Okay, that worked. So, slightly annoying thing, and this is why it's so nice to do the tidyverse approach, because it kind of sorts out a lot of these little fiddly things. But, you know, you might, say, end up with a job where you got to look at a really old code base. If you are, say, working for a bank, banks use old software because it's proven, right? They don't use the cutting edge stuff because who knows if there's a mistake in there. If you work at a bank that's using R to, say, calculate credit scores or to, you know, assess whether or not someone should get a loan, it might be written in base R. So it is useful to see base R, even if the more modern approach is with tidyverse. So, slightly annoying, as vector. So let's go ahead and add to each of these. You notice I'm going through this relatively quick because Vim key bindings make a lot of things a lot faster for editing text. Vim is a famous text editor that I really like, but it is very difficult to learn. So this is the sort of thing that you learn when you're looking to procrastinate studying for midterms. That's how I got into Linux as an undergrad. Had midterms coming up, said, let's try almost ruining my computer by figuring out Linux. And then once I did that, I started figuring out Linux utilities like Vim. So let's go ahead and run all these. No errors. That's a good sign. And then, as I was saying a minute ago, we're creating the same unique location value in pop, and that's just going to make it easier for us to merge this stuff back in. So this, I think, was mean in df. That merges fine. Let's just look at out df. All right, that's too much. Let's look at the head of out df. The first 6 rows, so we got a unique location, we got a state and county code, we've got a state and county name, we've got population, births, deaths, and a mean in migration rate. And this looks great. This looks like what it's supposed to look like. So now we're going to take this data frame and we're going to merge in other things. It would be really nice if we could chain this together, but we just have to merge line by line. So we do all of this, and now we've got out df, our data frame that we want to spit out as a result. We can write that to a CSV. Now there's a little teeny thing which is kind of annoying. Let me show you. So when we look at out df, we've got 18 variables. Everything looks fine, I'm just going to scroll down to the bottom to see if there's any NAs, missing values. That looks fine over here. Let's sort on something from the flows data and check that again, if it'll let us. Scroll way down, see if we got any NAs. Looks good. Cool. We do have Kennedy County, Texas, 0 births in the year 2020. There's only 346 people, so, you know, understandable. Cool. So we have merged everything. You know what I should have done is I should have saved this as something with a different name. So let's call this summary underscore base R. Write that. Cool. So we put it all together. We've done the basics of this task. This video, I did this in 15 minutes, partly because I already had the code written out, but mostly because I've just been struggling through this for entirely too long, let's say. But you struggle through and you build skills. Like I've said, I'm rusty on this, so if I were to run into this problem again in the near future, I'd get through it a lot faster. If I don't see this problem again for another few years, I'm going to be rusty again. But more important than being fast is being able to solve the problem at all. And to solve this, I had to do a bunch of detective work, and you can see a bunch of that if you watch the videos coming after this. All right, now, since we're here, and we got one video where everything's working right, let's go ahead and just also do with the tidyverse approach, and then we can also verify that this is going to work correctly. So let me just source everything. I'm going to run through everything. Notice when we load in the tidyverse, it spits out some stuff, or in this case it didn't, because I already loaded that in, but we're getting some output when it's joining stuff. It's not giving us any indication that things went wrong. If we compare summary.csv to base R summary, it is a bigger file. We've got 3 extra rows, 27 variables, so it's a little bit different, but let's see what we get. We're going to view this file, we're going to view this file, and we've got something similar. Standard out, mean in, county name, all this stuff. We've got basically the same stuff. Notice it's formatted a little bit differently. This is the base R one, and one slightly annoying thing is it adds in an extra column for the row name. So it's got row 1, 2, all the way down to 3140. You can get rid of that with some extra arguments in write.csv, which we're not going to worry about right now. But let's compare Autauga County. Here, Alabama, Autauga County, we've got our population is the same. If we got a 0.002 for standard deviation out, 0.002. All right, cool. So we got the same basic stuff. A little bit different. We got an extra decimal place with the tidyverse approach. We did calculate more things. We calculated means and medians and mins and maxes. And totals and nets. So that's probably why this file's so much bigger, is it's got a lot more data in it. But in any case, 2 different approaches. The base R approach, we did get it solved, right? We got through it. It took about 50 lines of code. And then our tidyverse approach took us about 40 lines of code, but it's a lot easier to read. And this is really the biggest reason to use something like the tidyverse. I mean, there are other reasons, right? Sometimes there's some optimizations that make it work faster. But for our purposes, the really important thing is that it makes the code a little bit easier to read. So that's in a separate video. I'm not going to go over that right here. But as usual, if you got questions, let me know in the usual places, and I will talk to you in the future.